Have you ever just stopped and wondered why time only seems to move forward? I mean, we remember the past, but we have no memory of the future. Things break, they fall apart, but they never, ever just spontaneously put themselves back together. This is so fundamental to how we see the world, and it's something that Christopher Nolan's movie Tenet just flips completely on its head. So let's dive in. We're going to explore the deep physics behind what we call time's arrow and what it would actually mean to hit reverse. It all starts with a super simple question, a question a kid might ask. You drop a glass, it shatters into a million pieces. We just know deep in our bones that it's never going to just leap back up off the floor and into your hand, perfectly whole again. We see this kind of thing everywhere, right? An ice cube melts in your drink, cream mixes into your coffee, but it never unmixes. Why is that? What's funny is that the basic laws of physics, things like gravity, they don't really care if you run the film forwards or backwards. So what's giving our world this relentless forward-only direction? And look, this isn't just some late-night philosophical question. It's genuinely one of the biggest mysteries in physics. Scientists have a name for this one-way street we're on. They call it the arrow of time. It's this simple observation that the past is fundamentally different from the future. So to really get why that is, we have to talk about one of the most important and honestly most misunderstood ideas in all of science. And that big idea is really the engine that drives time forward. It's this fundamental tendency for everything, literally everything in the universe, to move from a state of order to a state of disorder. It's a law not of what's possible, but of what's overwhelmingly probable. Okay, so that law is all governed by something called entropy. And I know, it sounds like a super technical, scary word, but stick with me, because at its core, entropy is just a fancy way of measuring disorder. All it is a way of counting all the possible ways you can arrange the tiny little parts of a system, the atoms and molecules, without changing what it looks like on the outside. The more ways you can scramble things up, the higher the entropy. And you actually get this intuitively, you really do. Think about your bedroom. A perfectly tidy room has low entropy. Why? Because there are only a few ways for all your books to be lined up and your clothes to be folded just right. But a messy room, oh, that has super high entropy. There are literally millions of ways for things to be scattered all over the floor. It's the exact same idea with an ice cube. That perfect, ordered crystal structure is low entropy. But when it melts into a puddle, those water molecules are free to jumble around in countless ways. That's a high entropy state. And this gets us to the absolute genius of the physicist Ludwig Boltzmann. See, here's the kicker. It's not actually impossible for all the air molecules in your room to suddenly rush into one corner. And it's not impossible for that puddle of water to spontaneously freeze itself back into a perfect ice cube. It's just staggeringly, astronomically, mind-bogglingly unlikely. The famous second law of thermodynamics, the one that says entropy always increases, is really a statistical law. Things just move toward disorder because there are so many more ways to be disordered than to be ordered. So, this one-way journey toward disorder, that's our reality. But what if you could grab an object, or even a person, and force their personal arrow of time to point the other way? Well, that is the brilliant, mind-bending idea at the heart of Tenet. The movie is really clever here. It doesn't talk about time travel in the traditional sense, like hopping in a machine and vanishing. Instead, it introduces this concept of inversion. It's a fictional technology that can literally reverse an object's entropy. It forces things to move from high disorder back to low disorder. So they don't just jump through time, they actually live through it, just backwards. And this is where things get really wild. In our world, a bullet fires from a gun, its energy spreads out. That's entropy increasing. But in Tenet's inverted world, a bullet hole in a wall seems to catch a bullet, which then flies backward into the gun it was never fired from. An explosion, that's the ultimate example of increasing disorder. It happens in reverse. Fire and debris get sucked inward. And maybe weirdest of all, an inverted person sees cause and effect backwards. They see the effect before the cause, which means from their point of view, they're kind of remembering the future. This all builds up to the movie's amazing core strategy, the temporal pincer movement. This is where you have a team split up. One half moves forward through time to gather information, while the other half gets inverted so they can use that information coming at the problem backwards from the future. It's just a breathtaking idea where time itself becomes the battlefield. Okay, so Tenet uses the language of real physics. It's throwing around words like entropy and inversion. But, it's a Hollywood blockbuster after all. So let's try and separate the actual science fact from the awesome cinematic fiction. This is the big one, right? The billion-dollar question. Could we actually build one of those turnstiles, reverse an object's entropy, and send it sailing backwards through time? All right, here's the breakdown. Can we reverse entropy? Well, yes, kinda. For really, really tiny quantum systems, scientists can actually do this in a lab, but there's always a catch. It takes a ton of energy, and you end up creating even more disorder somewhere else to pay for it. But what about reversing a person? Not a chance. I mean, we're talking about needing to control the exact position and motion of trillions upon trillions of atoms in their body all at once. The complexity it's just impossible to even imagine. And as for the temporal pincer movement, it's a fantastic idea for a movie, but it creates all sorts of paradoxes that our understanding of reality just can't solve. So yeah, while Tenet's technology is pretty firmly in the realm of fiction, the real science that inspired it tells us something incredibly profound about our own reality and the way we all experience time. So here's the big takeaway. The reason we have an arrow of time, the reason time moves forward, is entropy. Our universe began in an unbelievable state of low entropy at the Big Bang. It was almost perfectly simple and ordered. And ever since that moment, for billions of years, it's been expanding, cooling, and getting more and more complex and disordered. That journey, from that simple beginning to now, that is what we experience as the flow of time. And believe me, this isn't just some abstract physics trivia. It explains the very fabric of our lives. The reason you can even form a memory of the past is because that process actually increases the total entropy of the universe. This arrow of time is directly connected to the expansion of the cosmos. And it all comes back to that one huge mystery. Why was the Big Bang so special, so incredibly ordered in the first place? And this is why movies like Tenet are so great. They use imagination to help us appreciate the unbelievably beautiful and profound laws that are running the show in our own reality. So we're left with this deep, deep question at the heart of science. Down at the level of tiny particles, the laws of physics don't seem to care about past or future. But the big world that we live in, our world, absolutely does. The answer seems to be tangled up in entropy and the unique way our universe began. But it's a puzzle that's a powerful reminder that there are still fundamental things about time itself that we are only just beginning to understand.